Welcome to P. Clark Calc, Practical Calculus for the Busy Math Student. In this video, we're going to take a look at an example of dividing through an irrational function before finding its antiderivative. Here's an important example of a function that can be integrated using the basic integration rules. Quick summary of those. We have the fundamental one, the simple power rule. It says if you integrate x to the nth power with respect to x, you add 1 to the exponent, x to the n plus 1 power, and then divide by n plus 1. Don't forget your arbitrary constant there, plus c, and that works for all exponents out there except for -1, because that would result in division by 0. The special case of that's the constant rule. If you take the integral of k times dx, the antiderivative is kx plus c. And then we have the constant multiple rule. These are a direct result of the integral being an antiderivative. States that I can take a constant factor outside of the integral if I wish, or I could put it inside of the integral if it's useful there. And then, just like with derivatives, the sum and difference rule states that we can integrate terms independently, definitely not factors. And so we start there. The one thing we cannot do here, what is definitely very, very wrong, is to attempt to integrate the numerator and denominator here. So if I would say 4/5 x to the 5th plus 4/3 x to the 3rd minus x squared over 2 divided by 2 times x squared over 2, and then figure I better put my plus c on there, or we'll be in trouble. So if I try that, I mean, I'm not following the sum and difference rule, because when I have a fraction, the numerator is a factor and the denominator is a factor. So this is very, very wrong. Should never do that. And so we're going to get rid of that and figure out what do we do. And the answer here is a rewrite. And this is a very special case. If you look here, we have a fraction with a monomial in the denominator. When you have a single term in your denominator, a good thought is to look at your function in the integrand and say, well, can I just divide through? Can I divide each term in the numerator by the denominator, which is a property of fractions. So what we're going to do then is to write this as the function 4x to the 4th over 2x to the 1st plus 4x squared divided by 2x to the 1st minus 1x over 2 times x. And don't forget your differential dx, even though it feels like at this point in your integration career, it may not seem like that differential is doing a whole lot, but get in the habit of writing it there. It becomes apparent it's a very important factor there, and integrals without differentials really don't mean anything. So just kind of make some good habits here when you're writing your calculus. So when we do the algebra here, we have the integral of 2x to the 3rd plus 2x to the 1st minus 1/2 x to the 0. So we could go ahead now and take this integral, because we have a collection of terms that can all be done using the combination of these basic rules. I have 3 terms. A couple of them have constant multiples. I do have a constant, and I'm going to use the power rule, obviously. So rather than actually breaking it all the way down into multiple integrals every time, maybe at this point, if you've been practicing, you can go ahead and just do the integrals term by term. And that's usually what we mean when we say use the sum and difference rule in integration, just like in derivatives, where we understand we can just go ahead and do the derivative of each term. Here I'm going to do the antiderivative of each term. So, and we bring the constant multiple along for the ride. So the integral of 2x to the 3rd is 2x to the 4th over 4. And then our second term will be 2 times x squared over 2. We have a constant rule there at the end, minus 1/2 x. And then just remember our plus c, because we don't know what constant could be there, and it's a whole family of antiderivatives. They just all differ by the number at the end, the constant term. And for now, we don't need to know what that is. Now, to get the final version of our general solution, we're going to go ahead and just do our arithmetic here and clean this up. So we end up with 1/2 x to the 4th plus 1 x to the second minus 1/2 x plus c. So it's an important case of using the basic rules for integration. Those are all the foundation of those is the power rule, but the original version of the function is not at a point where we can go ahead and apply the rules yet. So just like with derivatives, sometimes an algebra first, calculus second approach is the best way to go, and this is a very important case. At the moment, there's no rule for integrating a fraction that's been developed at this point in your calc life. So we have to understand that it can't be expressed as a fraction at this stage of the game. So what are we going to do? And that's the answer. And even when you know all the rules of integration that there are to know, then this is still the way to do this particular problem. When you see that single term in the denominator, divide it through every term in the numerator, and then you can go ahead and apply your integration rules. If you'd like to learn more about integration or calculus in general, you can find those on my textbooks, available for a nice price on Amazon. Don't forget to subscribe to the P. Clark Calc channel if you liked it. And until next time, I'm P. Clark.